Sorry for the break. Issue of power, issue of the camera not being well charged. That's what's causing the problem. Let's continue from here. These are video 7. What I've done so far, this is what we are looking for, 8F3 minus N. What I've done so far is that I've done reversal. It will involve reversal because 3 minus N, there's minus in front of N. So for that reason, there will be a reversal compared to this. And I've told you that reversal simply means what? Take every sample to the opposite, to the negative of its former address. The sample at 0 will be retained, unchanged. So the sample at 0, the sample is the magnitude is 1, it will remain there. All other samples will go to opposite direction. Whatever is at 1 must come to minus 1. Whatever is at 2 must come to minus 2. Whatever is at minus 3 should go to plus 3. So that's the reversal. But we are not done. We have only implemented reversal. Let's now try to do shifting. To do shifting, that means 3 minus n equals 0. That means n equals 3. As a layman, let me just tell you that means just add 3 to these locations. That's what it means. In another way, whatever is at 0 is shifting to 3. Whatever is at 0 is shifting to 3. So this will become 3. So it's like just add 3 to all. This will be 4, 5, 6, 7, 8, 9. And this will be 2, 1, 0, minus 1, minus 2, minus 3, minus 4. Hello. What I will now do is that this will be the new addresses. So I'm going to clean this now. Hello. I'm going to clean this because by the shifting, 0 will no more be 0. It becomes 3. 1 will no more be 1. It becomes 4. It's like we are going to add 3 to all. Don't tell me that n is equal to 3. The meaning of this is that every sample, a sample at 0 will move to 3. Definitely sample at 1 will move to 4. Sample at minus 1 will move to 2. So I will now clean this. I will have to clean this. So let me move this up. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me clean this now. With this, we have done 2 steps. We have done the reversal, we have done the shifting. The remaining is what? Is the magnitude, is the scaling. So that means multiply everything by 8. So this 8 will become what? 64. This 4 will become what? 32. This 7 will become what? 7 times 8, 56. This 3 will become 24. This 1 will become 8. This 3 will become 24. This 2 will become 16. If we have, for example, we don't have it there. If you have minus 5, it becomes what? Minus 10. But it is not there. I'm just using it to illustrate for you. So, then there is also what we call resampling. Let me remove this. There's what we call resampling. Resampling. There's what we call resampling. Resampling. Suppose they ask me to get 2n, F2n, F2n. What this means is that from 0, we are going to be skipping 1. For example now, when we take, what samples are 0? I have 1 as 0. I will skip 1. I will get to 2, but I will write it as 1 here. The next sample is going to be 7. I will skip 1. I will write 2 here. The next sample is going to be 8. On this side too, I will skip 1. I will take this one. The next sample is going to be 3. next example is going to be 3, and that will be at -1. I will skip 1. The next example is going to be 0, 3, sorry, -2, -3, -4. This thing will be 0 at 3, 0, 4, 0. What are we doing here? We are resampling. Instead of taking sample at here, we are now taking sample at 0, 2, 4, 6. I will be recording it as, instead of 0, 2, 4, we'll be recording it as 0, 1, 2. So F2 of them mean from 0 skip 1, take the next one, skip 1, take the next one. That's F of 2n. So suppose I want F of 3n. Let's see how that one will look like. 0, you retain what is at 0, no problem, that's 1. For F3n, you are going to skip 2. Skip this, skip that. The next is what? 4. But it's going to be written as location 1. And then when you skip, since all the rest are 0, this is what you are going to have. 2, 3, 4. You are skipping 2, right? From 0, skip this, skip that. The next one is 2. This is 2, and that's going to be -1. So -2, -3, -4. It's like we are resampling. We are doing what? We are resampling. So for F2n, we are skipping 1. For F3n, we are skipping 2. And you write this address normally. You not say because you have skipped this one, you are not going to write this address as 2. No. 0, 1, 2, 3, 4. That means if it has been every day before, in this case, if it has been every day before here, it is every 2 days. It is every 2 days. It is every 3 days. So let me stop this one here. Okay, before I stop, let me introduce impulse function. Impulse function. I've mentioned it last week. Impulse function. Impulse function. Impulse function. I've told you delta of n. That means it's a single sample, magnitude 1 at 0. A single sample, magnitude 1 at 0. We can do shifting, n-1. That means n-1 equals 0, n equals 1. We are not saying n is equal to 1. We are saying shift. Whatever is at 0, shift it to 1. So what is at 0? This is supposed to be horizontal line. Don't mind my drawing. So 1 will not be at 1. No more at 0. You know that here it is at 0. Here it will not be at 1. If I give you 3 delta n plus 4, what will this mean? So first take n plus 4 equals 0, n equals -4. What are we saying? Shift whatever is at 0 to -4. So on this delta n, we have 1 at 0, it will now be at what? -4. But this 3 means it has to be scaled. You have to multiply by 3. So it's going to be 3. So that is that, this is that, and this is this. So with this, I think you'll be able to handle these signals as they come in your work. Thank you for listening. In the next video, I will return back to Z transform. Thank you.